Welcome back to another exciting day in mathematics. Warm-up number 80 is on the screen. Let's get started, please. And once again, you don't need any Chromebooks. We're gonna do a detox, see how that goes. Some of you are gonna start like twitching and stuff. Anyways, get started, please. Go. All right, show your neighbor your table for warm-up number 80. See what they got. See if they have something similar to yours. All right. We good? Yeah? All right, so how many total outcomes? What was N? Tell your neighbor, what was N for that? N was, I think Carter's got this one. What do you get, Carter? N is, pass it to Cole. Cole, N was, okay, Brandon Daugherty. This is the third pass, so after that we can't pass it anymore. Brandon Daugherty, N is, damn, 18 is correct. So, make sure you get that table done. Copy the agenda, please. Warm-up number 80, complete. Addition rules of probability. Tonight's home play, pages 206, 207, numbers 1 through 7, odds only. Today we're moving on, and once again, no Chromebooks, please. Appreciate it. We're on a detox tour. No mobile devices. What? And so yeah. So let's see how you do with your tech. You're gonna actually open your textbook. What? Ooh-wee. You do have a textbook. It's at home, somewhere, in that little corner where you place it to, No, what, Cole, what? To do your home play. Which one? All right. Here's to access the presentation, VRCGE. VRCGE. So today we're moving on, and we're going to start adding some rules to the rules that we already have, but now we're going to actually be using some of those formulas. Okay? So, to get started, we talked about probability. We already know definitions. By the way, last night's home play, 198, 199. I'm going to upload that till the afternoon because I was having some tech difficulties earlier. So, as I was saying, we're going to be moving on to some of the rules. So, get a Cornell note ready, please. I can identify and compute the basic probability. I can identify and compute the basic probability. All right. So, as I was saying, we talked about probability being the chance of an event occurring. We talked about the three different types of probability we've been talking about, classical, empirical, and subjective. Which brings us to today. Since you don't have any electronic devices to Google or GPT or whatever it is you guys do, TikToking, tell your neighbor what exclusive means. What does exclusive mean? What does that mean? Exclusive. All right. Looks like Cole was the last. Oh, no, who went last? Brandon Daugherty. Pass someone back, Brandon. Cole, what do you think exclusive means? Unique. Let's go. Unique is correct. Now, I'm going to use an example really quick. Like, for example, me. My relationships are really, really exclusive. So in order for me to have someone close as a friend or someone that I have a relationship with, I'm very exclusive about that. So out of my whole life, I can count my friends with one hand, and I have fingers left over. So how about them apples? So, and some of you are saying, let me think about that one. Yeah, like you have in your life some of your friends, but there's those that are exclusive your friends in the sense that when you are going through something bad or something good, they are there. Does that make sense? Yeah? So, according to the definition of a dictionary, exclusive means having the power to exclude, limiting or limited possession. You don't have to copy this. Excluding others from participation, and then there's other adjectives in there. So, let's keep it at that. So, why am I bringing this up? Because today we're going to be talking about event and probability. There's two types of events that we're going to be talking about today. Mutually exclusive and not mutually exclusive. So copy that, please, on your notes. Events, mutually exclusive events, and not mutually exclusive events. Today we're going to be looking at both. We're going to be talking about a couple of formulas, one for each of those, and applying them to word problems to make sure we understand them. So, what are mutually exclusive events? Mutually exclusive events are events that cannot happen at the same time. Mutually exclusive events are events that cannot happen at the same time. Mutually exclusive events are events that cannot happen at the same time. So if that's mutually exclusive, tell your neighbor what not mutually exclusive events are. What are not mutually exclusive events? Cole, pass someone. Brandon, what is not mutually exclusive? Ooh, that can happen at the same time. That is correct. So, here we go. So watch. Let's say, I'm going to first give you the example of not mutually exclusive. That means that events that can happen at the same time. So, let's say I have, I get Austin T over here in the front, and then I spin him around and tell him to cover his eyes, and then I tell him to point to one of you after he stops. What is the probability of him pointing to a senior? 100%, right? Okay. However, what is the probability of pointing to a senior that's in sports? You see what I'm saying? Now, can both things happen at the same time? Someone being a senior and in sports? Yes. Those are not mutually exclusive. That means that they can happen at the same time. Now, let me show you one that is mutually exclusive, which means it cannot happen at the same time. Let's say I gave, thank you, Austin T. I said, all right, Cole, I'm going to give you some cash, and here's the roulette. And you're going to place some money down, and you're going to say, I'm going to place $10,000 on black. Now, when the marble stops, can it land on black and red? No, that's why this is called mutually exclusive. It cannot happen at the same time. Now, by the way, the green one is the 0 or double 0. It pays like times 10. So, Anyways, you guys get the idea, yeah? All right, so for mutually exclusive events, there's a formula. So write this formula down, please. For addition rule number 1, write addition rule number 1. You don't have to write the verbiage, just copy the formula. P of A or B is equal to P of A plus P of B. Write that down, please. And as you write down the formula, I'm going to read you the rule. The addition rule number 1 says, for mutually exclusive events, when two events A and B are mutually exclusive, the probability of A or B will occur is P of A or B is equal to P of A plus P of B. Okay, we good? All right. So once again, the formula is P of A or B is equal to P of A plus P of B. Okay? So with that said, copy this problem on your paper. Example Q. A day of the week is selected at random. Find the probability that it is a weekend day. I'll give you some time. Copy and go. So it reads, a day of the week is selected at random. Find the probability that it is a weekend. So let's start with our formula. Tell your neighbor the formula without looking at your notes now. P of A or B, which is equal to P of A plus P of B. All right? So, with that said, it says, a day of the week is selected at random. What is the probability that it's a weekend? So, tell your neighbor what days are the weekend. Brandon, pass someone. Aaron. Huh? Yeah, which ones? Saturday or Sunday. That is correct. So we're going to write P of Sat or Sun, which is P of Sat plus P of Sun. So P of Sat or Sun is equal to, so think about it. It says, a day of the week is selected at random. So question, what is the probability that it's a Saturday and what is the probability that it's a Sunday? Talk about your neighbor, let them know what you're going to write for Saturday and for Sunday. All right. Aaron, pass them one. David, Saturday. With it? You passed to Brandon? Brandon. 1 out of 7. That is correct. Write that down. Which means, obviously, that for Sunday it's what? 1 out of 7. So therefore, the probability of picking a day that falls on the weekend is 2 out of 7. All right? How are we doing? From 1 to 5? Yeah, we got this, right? Let's do another one. Copy this one. Example Super Q. For this one, don't copy the verbiage. I just want you to write Super Q, and then let's write the formula to get started. P of A or B equals P of A plus P of B. All right, here we go. And it reads, Imperial County has 17 coffee shops. Now, I didn't check this morning. This is from last year. I didn't check to update it, but let's see if it's still current. 9 Starbuckses, 8 independent coffee shops, which are 316 Cafe, Brick House, 2 Hope Cafes, 1 Surf and something. What is that called? I don't know if you guys bought from that little orange van. Have you guys seen a van that parks at places? No? There's a van here in the valley that parks sometimes in Brawley and El Centro. It's an older van, kind of like those Scooby-Doo vans. And it opens from the side, and the guy comes off and starts making coffee on the street. So, anyways, that's that. Pepper Grind. Have you guys been to Pepper Grind? Pepper Grind is in El Centro, right across from the hospital on Imperial. On that street, it's called Pepper Grind. Anyways, if you go, get one that I like to get there is the Dirty Chai. They put a espresso shot in there. Fire. Sweet Nothings is a coffee shop in El Centro on Main. They sell pastries that are sugar-free. How about that? You guys do sugar-free here for the Tiger Cafe? You're like, no, we pour that sugar in there. My goodness. Cole, do you put a lot of sugar on the stuff? No. On the pastries that you make. What? Then how come you come with a big old cookie sometime? Yeah, I just let my teammates do the work. Wow. Anyways, and Honey Buzz and Brawley. So anyways, those are the coffee places. Question. It says, if a person selects a shop at random to buy a cup of coffee, find the probability that it's a what? Starbucks or Pepper Grind. So, put P of star or pepper. So that would be P of star plus P of pepper. All right? Talk to your neighbor. Let them know what you're going to write for P of star and what you're going to write for P of pepper. Make sure you read the problem, please. I'll give you some time. Go. Brandon, pass them on. Ooh. All right, Mel. P of star. 9/17. That is correct. Therefore, P of pepper. Pass them on. 1/17. Therefore, the probability of the Starbucks or a Pepper Grind is 10/17. Pretty straightforward, yes? From 1 to 5, how comfortable are you with this? 5, 5, 5. We got this, right? All right. Last one, example mega Q. On your notes, copy only this table right here that I'm boxing. Just copy that. And it reads, example mega Q. The corporate research and development centers for the 3 local companies have the following number of employees. U.S. Steel has 110, Alcoa has 750, and Bayer Material Science has 250. If a research employee is selected at random, find the probability that the employee is employed by U.S. Steel or Alcoa. So you should be able to do this one completely by yourself. Ready? Go. And also talk to your neighbor just to make sure that they understand what you're doing for that one. I'll give you some time. Go. All right. Kern, tell me what to write. Yeah? All right. And then you wrote? Hold on. Does it look something like that? Okay. So, P of US or Alcoa is what? Pass someone so they can help me with the numbers. Liani, for US. $750 over 110. Hands if you got something like that. All right. So therefore, the probability of those two is 860 over 1,110. And if we simplify that, that's what? 86 over 111. Hands if you got that. All right. So we're good with mutually exclusive, yes? So, now that we got those down, let's go to not exclusive. Copy this formula down, please. Addition rule number 2. P of A or B is equal to P of A plus P of B minus P of A and B. P of A and B. What's the only thing you see different, Aleshka? Yeah, we're subtracting P of A and B. Okay? So, let's go to a problem really quick. So, for this one, example 2Q, writing utensils down, look up. So it reads, on New Year's Eve, the probability of a person driving while intoxicated is 0.32. The probability of a person having a driving accident is 0.09. And the probability of a person having a driving accident while intoxicated is 0.06. What is the probability of a person driving while intoxicated or having a driving accident? So, for this one, example 2Q, start with the formula. Write the formula. P of A or B equals P of A plus P of B minus P of A and B. All right? So check this out. For these, I have to go back to the problem, reread it, and understand all the components. Here it goes. Look up. It says, in New Year's Eve, the probability of a person driving while intoxicated, I'm going to underline that in red. Intoxicated is how much? 0.32. The probability of a person having a driving accident is what? 0.09. However, look at the last part. The probability of a person having a driving accident while intoxicated. What does that mean, Mr. Q? That this is both intoxicated and also having a what? Accident. Both together. So with that said, tell your neighbor what we're going to write here first, according to the question. Then Max is going to enlighten us. Talk it over to your neighbor. What is the probability of a person driving while intoxicated or having a driving accident? What do I write in here to get us started? Tell your neighbor, please. Hey, you guys all right? All right, Max, go. What do I write? Intoxicated or accident. That is correct. Intoxicated or accident. Which means P of intoxicated plus P of accident minus P of intoxicated and accident. Yeah, so far? All right. So, with that said, I got P intoxicated or accident is equal to, tell your neighbor what to write here, here, and there. Talking to your neighbor. What do I write there, and there? All right, Max, pass someone. Alessandra, for P intoxicated is 0.32. That is correct. Which means the accident is 0.09. However, the last part, pass someone, Alessandra, for the last part. 0.06, so that one, I'm going to do that in green, just so that we do the last part in green, so 0.06. So therefore, the probability of being intoxicated or in an accident while driving is, calculators calculate, Alexa, pass someone. Santi. .35. And that's how you use the formula with two mutually not exclusive events. Does that make sense? Yeah? Okay. All right. Let's go to the next one. Example 2 super cute. And it reads, in a hospital unit, there are 8 nurses, 5 physicians, 7 nurses, 3 physicians are females. If a staff person is selected, find the following that the subject is a nurse or a male. Copy this poem completely. Copy the words, please, onto your paper, please. And then we're going to do this one together because it requires one more step before the formula. One more step before the formula. Go. All right, so for this kind of problem, guys, it's not straightforward because they don't give us percents or probabilities up front. For this one, we need to actually organize our information. So here we go. They're talking about staff, and they're talking about nurses and physicians. They're talking about males and females. So therefore, let's start here by writing staff. What kind of staff are they talking about? They're talking about nurse. Nurse. They're talking about physician. Physician. All right. They're talking about female and male. And this kind of table should look familiar. The totals go here and here. All right. So, fill out the table, please. I'm going to give you some time and look it over with your neighbor to make sure they got the same numbers as you. I'll wait for y'all to finish that table. It's a two-way table. Go. All right, get us started. Vianney, what goes where? Give me a number. The female nurse is 7. Okay, female nurse is 7. All right, pass someone. Kieran. Male nurse is 1. Pass someone. Physicians. Female or male? Female? How many? 3. Pass someone. Two. All right. Pass someone for the totals. Austin S. Nurse total 8. All right. And have you got that by yourself? All right, so now that we have that, start with our formula. P of A or B is equal to P of A plus P of B minus P of A and B. All right? So, question is, if a staff person is selected, find the probability that the subject is a nurse or a male. So therefore, P of N or M. Yes? N for nurse, N for male. So we write P of N plus P of M minus P of N and M. So with that said, get me some numbers, please. Write some probabilities down, check with your neighbor. Use that table for the information. I'll give you some time. Go. All right. Who went last? Austin, got someone? Brandon. Eight out of 13. So P of N, which is nurse. So how many nurses? 8. How many total? Staff? 13. That is correct. All right. Next, P of M. Pass someone? Mel? 3 over 13. So male, there's 3 of them out of 13, okay? The last one's a tricky one, though. Talk to your neighbor, let them know what you're going to write for P of N and M. Then Mel's going to pass to someone. Lulu. Okay, the last part is probability of a nurse and a male. 1, that is correct, out of 13. Where does the nurse and male intersect? Right here, so it's 1 out of 13. Both happening at the same time, yeah? So therefore, the probability of a nurse or a male is 8 13ths plus 3 13ths, that's 11 13ths minus 1, that's 10 13ths. All right, from 1 to 5, comfortable are you with this? 5 4s, 5 4s. So we'll stop right there, guys. So, do your practice tonight with that home plate, please. Those of you following on YouTube, make sure you get your practice in with that code that you got at the beginning. I'll see you guys next time. Peace.